In today's video, we're going to explore Chainlink's new Chainlink Runtime Environment, or CRE in short, and discuss why it could be one of the most significant innovations for Web3 and DeFi in years. Chainlink is already well known as a leading decentralized Oracle network, connecting blockchains to real-world data, but CRE is expanding on Chainlink's original vision, pushing the boundaries of what's possible on the blockchain and unlocking new applications for developers and enterprises alike. Before we continue, I want to ask you to leave a like and subscribe. That will help out a lot, and I will be making more content during this bull market that could potentially help you make certain choices.
I think the CRE really is the final piece of the puzzle for us. It's this thing in the system that's going to enable the interconnection of hundreds of Oracle networks, thousands of chains, all the world's data, all the world's payment systems into a single application.
Announced at Chainlink SmartCon in Hong Kong, CRE is designed as an all-in-one environment for blockchain application development. Chainlink's co-founder, Sergey Nazarov, explained that CRE could be as revolutionary for blockchain as Java Runtime Environment was for the internet development back in the 90s. Java's GRE provided a consistent universal framework so apps could work smoothly across multiple platforms. And similarly, CRE aims to bridge gaps between different blockchains, allowing applications to operate across them without need for custom code adjustments. Nazarov compared this moment to the impact of legacy programming languages like COBOL, which transformed the finance industry decades ago, and JavaScript, which made modern web development possible. Just as those technologies became fundamental in their respective eras, CRE could serve as a keystone for blockchain's next phase. To understand why CRE is so innovative, let's break down how it works and what sets it apart. Fundamentally, CRE is a modular environment with a strong emphasis on privacy, interoperability, and scalability. CRE accomplishes these goals by leveraging decentralized Oracle networks, or DONs, and advanced cryptographic tools like zero-knowledge proofs and trusted execution environments. In simpler terms, DONs are clusters of independent nodes that perform specific modular tasks, such as reading or writing data on or off-chain. By decentralizing these tasks, DONs allow each component of a blockchain workflow to be secure and independently matched, creating a building block approach that makes it easy for developers to customize, update, and expand applications. But why are DONs such a critical innovation? Traditional blockchain applications are typically constrained to one specific chain and are often difficult to modify or scale due to the tight coupling of components. This traditional architecture limits developers' ability to build adaptable cross-chain workflows and restricts access to certain data or services. With DONs, Chainlink has created a structure that can perform various tasks independently and combine them as needed, making applications more flexible and allowing workflows to draw on resources from multiple chains and data sources. This is especially useful for financial applications, as the decentralized structure of DONs enables real-time data processing with privacy features that align with regulatory requirements, which is crucial for traditional financial institutions entering this blockchain and Web3 space. Another key innovation of CRE is its chain-agnostic design, meaning that it can operate independently of any particular blockchain. In traditional development, when you build an application on one blockchain, it often requires extensive adaptation to function on another chain due to differences in data structure or code and functionality. CRE eliminates that problem by providing a unified development environment that enables developers to use Chainlink services and resources across any chain. This flexibility is transformative for Web3 because it removes the barriers for developers who want to work across multiple chains. Essentially, CRE allows developers to create workflows that are not limited by the constraints of any single blockchain, opening up endless possibilities for applications that require interoperability across different ecosystems. Privacy and compliance are also crucial components of CRE's design. As blockchain technology has grown, privacy has emerged as one of the primary concerns, especially for institutions considering blockchain adoption. The financial industry, in particular, relies heavily on data security and strict regulatory compliance. Traditional blockchains were not designed with built-in privacy features, leading to challenges for institutions that handle sensitive data. CRE addresses this issue through advanced cryptographic techniques like zero-knowledge proofs and trusted executive environments, which ensure that data can be processed privately, even across these public blockchains. Zero-knowledge proofs allow CRE to validate information without exposing the data itself, which is essential for financial institutions that must comply with data privacy regulations. TEEs provide a secure area of execution within a blockchain's infrastructure so that sensitive computations can happen confidentially, further bolstering privacy for complex financial workflows.
It will take them from doing it over the course of months and weeks to days or eventually hours.
For developers, one of the most attractive features of CRE is how it can reduce development time and streamline workflows. Nazarov mentioned that tasks that might even take weeks or even months to develop can now be accomplished in days or hours with CRE. By bringing the entire development process into one environment and enabling workflows to be composed within a single code base, CRE reduces the need for developers to switch between different environments or just to adjust code for compatibility with different blockchains. This streamlined workflow makes it far easier to build applications that incorporate a variety of Chainlink capabilities, such as CCIP, data feeds, and automation. An important component of CRE rollout is that Chainlink will introduce it in different phases. Right now, CRE is in an early access stage so that developers can begin testing it out and integrate it in features into their current workflows. The full rollout is planned for next year, which will give developers ample time to explore and familiarize themselves with CRE's tools before they become widely available. This phased approach is similar to how Ethereum introduces its updates, allowing time for technology to mature and the community to adapt. In the context of Chainlink's journey as a platform, CRE represents a significant evolution. The Chainlink platform originally consisted of pre-packaged services, each with its own set of capabilities. For example, Chainlink Automation combines several features to create smart contract automation workflow. However, as the landscape grows, so has the demand for more sophisticated applications and customization. Chainlink recognized that to scale effectively and meet the needs of both DeFi and TradFi, it would need to move from a service-oriented model to more modular developer-centric approach. Through CRE, Chainlink is unlocking what it calls limitless developer innovation. Instead of only using predefined services, developers can now create custom workflows using capabilities that include off-chain data access, automation, cross-chain computation, and compliance functionalities. Chainlink's plan to support multiple programming languages for workflow development, such as Go and TypeScript, which will be compiled into WebAssembly for execution on Chainlink nodes. By giving developers the ability to use familiar programming languages, CRE lowers the barrier for entry and makes it easier for newcomers to start building decentralized applications. Ultimately, the Chainlink Runtime Environment has the potential to redefine the standards for how decentralized applications are developed, particularly in sectors that, again, rely on privacy, security, and interoperability. With its modular architecture, privacy-focused tools, and cross-chain compatibility, CRE could definitely lead to a new kind of blockchain-based applications that extend beyond DeFi into areas like capital markets, healthcare, and data management. As CRE progresses towards full release, the possibilities for innovation on the blockchain are expanding at such a rapid pace.
I really do believe that if we're able to pull it off and get it into the hands of the right developers, we already have the services, we already have the integrations with the relevant chains, we're getting the integrations with all the largest existing payment systems, we already have AI working on Oracle networks, confidential computing is entirely possible on Oracle networks in this model. If we can provide all of that through a single service and platform that people can interact with using their existing languages and models for building applications, then I think eventually the vast majority of blockchain-based applications can be built through this standard.
By offering an environment that's as adaptable and comprehensive as the GRE was for Java applications, Chainlink CRE might indeed prove to be as transformative for Web3 as GRE was for the internet. This environment could empower a new wave of blockchain applications that redefine industries, paving the way for a decentralized future. Let me know in the comments what you think about CRE. Don't forget to subscribe for more updates on the latest blockchain innovation. Thank you for watching. Cheers. Bye-bye.